Please go through this exam message properly. A quick, say, briefing on the midterm exam. So which we are.
Sir.
Yes.
I have to the form, or can I write in my paper on paper?
No. This is what I'm announcing now. So if you see here, so we will have on our Tuesday. So please show up at least 20 minutes before 7 p.m. 20 minutes before, so that we can arrange ourselves, cameras and everything, and start on time. So I want everyone to show up in our Zoom meeting room at least by 6:40, so that we can check everything. Okay, so material is already noted. Just to let you know, guys, that for this exam, we are not using the Respondus Lockdown browser. As I have mentioned, that we may require some more time to look at its effectiveness. So that's why for the midterm exam, we have decided that to use that. Okay. And please, you must switch on your side cam. Your side camera should be in this manner, where I should be able to see the screen, your hands, your desk, and your side face. This is very important, I'm telling you. And these are the other notes. So just look at these notes properly. For the calculated formula problems, we only require numbers. We do not need to include any units of the quantities like degrees or the angles, or degrees for the angles or the directions of the vectors, and give up to 3 decimal places. That is, after the dot, at least give 3 values. Okay. And what we are also doing is we are also going to put all the figures which will come in the exam in a separate folder, which will be there in the midterm exam area. So anytime you can open that and you can check if for some reason the figure does appear on the blackboard. Okay. Now this is a very important announcement. So please, try to understand these announcement, that we are going to have some MCQs and the calculated formulas. But we are going to validate your MCQs and calculated formulas with the handwritten solution that you are required to upload immediately after the exam. And that for this reason, we have already created a template here. So this is the template. So please print enough number of sheets and keep it with you. And please follow this template to do your handwritten solution. So we have given enough space for you. So you can side and this side, and then you can put your final answer, what you have decided here. And suppose you think that this half page is not enough, then you can scratch this and then continue here. Okay.
So there is partial credit.
Say it again.
Partial credit.
No, there are no partial credits. This is what I'm clarifying. These are only used to just validate your answers. Okay, this is what decided, and this is the instructions from the department. So we are going to validate this.
If my answer is wrong, if my final answer is wrong, and my step is correct.
No,
I will
if your final answer is wrong, then your question will not be validated. We will not go to your questions. Okay, so these handwritten solutions are only, so that's why I'm coming to the announcement. See, so it will be validated with handwritten solutions that must be submitted after the exam. Then the submitted solutions carry no partial grades, but will be used for verification purpose only. If there is no solution or incorrect solution in the handwritten submission, then the grade of that question will be 0. Hence, no grade for guesswork. Okay, so please go through this point. So this is making very clear that we will validate your questions using your handwritten solution.
Doctor, is this
Yes.
even for MCQ?
Yeah, even for MCQ.
Doctor,
Yes.
What if the question is concept?
If the questions are conceptual, then you do not need to write anything. I mean to say, if they are theoretical questions. Okay.
How many questions, Doctor?
So your exam is going to be divided into 3 parts. And in each part, you are going to get 6 questions. Yes. In each part, you are going to get 6 questions. So there will be total 18 questions. And for all 18 questions, you will be given 1.5 hours, 90 minutes. So each part is 30 minutes. Okay?
Doctor,
Yes.
can we print the formula sheet with us?
Yes.
Or
Yes, yes, yes. This is what I have, it is written here. See, please make sure that you are ready with a calculator and the course formula sheet given by the instructor. So you can take a print of your course your formula sheet, which is the 3-page formula sheet, and keep it with you. That's it. Only only these 2 items should be there on the desk. No books or notes allowed. And you have to use only hard copy of the formula sheet. So that's why take a print of the formula sheet and keep it with you, and take the print of your solution template, which we have posted, and keep it with you. So make enough copies. I have already told you that there will be 18 questions. So accordingly, you print and keep enough copies with you. Okay. So
I didn't understand about the MCQ. All MCQ should be write the solution for all MCQs, even the concepts.
I have just now answered that. I told that for conceptual questions, which are theoretical, those conceptual questions, you do not need to write anything in the solution template. But those MCQs which requires you to do hand calculations, then that must be there in the solution template. Okay. Because we are going to have both. We are going to have both varieties. We are going to have some conceptual questions, and we are going to have some questions which requires you to do a hand calculation. So all that handwritten solutions should be there in that answer sheet. Okay.
Doctor,
Yes.
can you reconsider the partial grade part? I think it should be given partial grade. It's more fair to the students.
No, I think, guys, we already discussed about this, and already, this was, so not just our instructors, besides the instructors, it is also within the involvement of the department as well. And this is what we decided. And unfortunately, it is out of my hands. I can't do much.
Doctor, you can talk with Dr. Masoudi. We have other courses in EE, and not the instructions not like this. This is like against the students. I mean, if every question is 5 minutes, and then there is no partial credit, how can I put my answer in correct way, and how can I not miss subtract or add or?
Yeah, guys, there is one thing which I wanted to clarify this, and I did it even for the quiz. Remember, we are giving 18 questions, but remember, we don't expect that all the students will attempt 18 questions. Okay, so we are giving you more questions. Yes, the time is limited, but in the end, as I am doing for the quiz, and we are going to do the same thing for the exam. In the end, we are going to take who is the maximum student, the student who got the maximum grade, and his maximum grade, we are going to upgrade to the maximum of the midterm exam. And the maximum of the midterm exam is 22%, if I'm not mistaken. So he will get the full grade. He will get the full 22 grade. And accordingly, all the other students will be scaled up. Okay, and this is what we are going to follow in the exam. So really, we don't expect that all the students will go and do all the problems. Okay, so again, I'm repeating, we don't expect the students to do all the problems. So now, you know, it's you guys, when the question comes to you, I really encourage you to skim through the questions and start doing the problems which are much easier. So start from the easier problems. Okay, from the 6 questions that you will get in part 1, first look for the easier problems and do it. And then start addressing the, you know, say average ones and then the difficult ones. So in conclusion, we do not expect that every student will go and every student will, you know, do all the 18 questions. So we want to encourage you to go and attempt all the questions, a sort of competition, but at the same time, we know that, you know, you can, all those, you know, all students, it will be difficult, and to get the maximum, which is 22%, is also difficult. So that's why we decided that we are going to help you guys. So whoever get the maximum score, he will be scaled up to the full marks. Okay.
Doctor, question, please.
And one more thing, guys. See, these decisions are not just within the instructors of EE340. Remember one thing, I wanted to clarify this. It's not just between the instructors of EE340. We also got guidelines, we also got instructions from the department. So we have to abide by those instructions. And these are the strict instructions that have been released to all the department instructors just last week. So we have to follow that. So, you know, try to understand that. Yes. Any other question?
Yes, doctor.
Yeah.
Maybe I didn't read the full form of the midterm exam instructions, but will there be backtracking?
For parts, yes, they will be backtracking. So for each, it's up to us. You can go and look at all the 6 questions and decide whichever you want to do.
Okay.
Okay, so there is no, so we are not stopping the backtracking in the exam. Just keep this in mind. So for every part, you can go and look at all the 6 questions and decide whichever you want to start. Okay. Okay,
Doctor.
so let's start our lecture, and we need to finish 15 minutes before because of our quiz.
Doctor, just one more question.
Go ahead.
Is it section by section the average, or gonna be the whole?
No, it will be the course average, because in the coordinated courses, this is what the department is following. So it will be the course average, not the section average. And also remember, you know, in the end, all the grades, letter grading and cutoffs and everything will be based on the complete course, not by section and section. Okay, so just don't worry about the section averages. You know, you have to look at the course average. That will give you where you stand. Okay. So let's start our class. In the last class, if you remember, we started the Maxwell's equation, and we looked at the Maxwell's equation in the final form. And then we started with the waves. So where we tried our best to see how the electric and the magnetic field behaves, okay, when we look it in the free space. So we are making our say problem very simple. We are not looking at the source where the electric and magnetic field are generating, because that will be a little bit complicated. But we are seeing that if we are looking in the free space, and if my electric and magnetic field are generated by an AC source, AC current or AC voltage, then how does this electric and magnetic field looks like in the free space? And this is what our objective is. And that's why we took the Maxwell's equation in the general form. And then from there, if you remember, we derived a wave equation. So this is called as a three-dimensional wave equation for the electric field. And then we again decomposed this because this is vector. So we decomposed to scalar wave equations, where Ex is the component of my electric field along the X, Y, and Z directions. And remember, your electric field components can be a function of all the three space variables, X, Y, Z, as well as time t. So here, fourth variable also coming into picture. So from now onwards. Now, similarly, as I told you, we can also get a vector wave equation for the magnetic field, because here our starting point was this equation. And we were substituting this equation here. So for the magnetic field, your starting point will be this equation, and then you will substitute the first equation there. And if you do that, again, you will get the very similar vector wave equation, which if you decompose, you will get the 3D scalar wave equation, which is like this. So Hx, Hy, Hz, and Ex, Ey, Ez. And if you see all these equations, 6 equations, 3 and 3, they follow a similar pattern of your differential equation, similar pattern. And therefore, what I'm doing is, rather than going and looking at them individually, we will just put it in a very general form, and that general form is F. So it is del square F is equal to mu epsilon dou square F over dou T square. And where F can be any 6 components, Ex, Ey, Ez, or Hx, Hy, Hz. And remember, each of this component is a function of X, Y, Z, and T. So therefore, you rather than looking each of them individually, I have all put them in a general expression, which is a 3D scalar wave equation, and where F can take any of the 6 components, and F is a function of the spatial coordinates and the time. And now let's go and look into this general equation and see how its solution looks like. And whatever is the solution, that will be the solution of all these 6 components. So now, we are now making our differential equation even much simpler. So this is the 3D scalar wave equation, right? So now we have F as a function of X, Y, Z, and T. So now we are making it even much simpler. So what we are saying that, let us just suppose that my function F, which are any of the 6 components, is only a function of Z, not a function of X and Y. So this is what I am assuming for simplicity. F is F of Z, T. And this assumption, guys, comes again from the experience, because you will see that in all these wave propagation phenomena, usually Z, it will be the function of Z, your components will be a function of Z, whereas for this X and Y components, you will see that there will be some way it will be fixed in value. So that's why we are assuming this as the simplification. Now, if we do that, so let's now substitute in this our general equation. So what we will get? First, let's open del square F. This is the opened del square F, and this is the right hand side. And now, just now we have told that now my F is not depending on X and Y. So therefore, I am neglecting X and Y. So this is 0, this is 0. So my equation is dou square F over dou Z square is mu epsilon dou square F over dou T square. So from the 3D scalar wave equations, why I'm using the word 3D? Because it was depending on all the 3 space variables. Then from there, I have simplified it to 1D scalar wave equation, because now my f is a function of only 1 space variable. Time is already there. So this is 1D scalar wave equation. And for this 1D scalar wave equation, we are just, modifying it to write it in this format. So dou square f over dou z square is equal to, rather than mu epsilon, I'm writing that as 1 over u square dou square f over dou t square. So if I do like this, then my u is nothing but 1 over root of mu epsilon. And why I'm doing, I'm modifying my 1D scalar wave equation to this format, because this is one of the standard second order differential equation format. And the solution to this equation will be in this form. That is, any f which has z plus or minus ut will be a solution of this 1D scalar wave equation. That's one. And what can be this f of z plus or minus ut? It can be any of this. All these will be the solution of my this differential equation. It will be the solution of my this differential equation, because now f is very general. So here I'm saying that f must have, it should be a function of this. Now, what can be f in mathematics? I'm talking about mathematically. F can take any of these forms. It can be a cosine, it can be a sine, it can be an exponential, it can be a sine plus cosine. But since see, all these are function of z plus ut or z minus ut, so they all satisfy the 1D scalar wave equation. Okay, 1D scalar wave equation. Now we will look at it. Which one do we need to select? Because remember, in the last class, I told you we are just doing and trying to understand how an electromagnetic wave will look like in free space mathematically. Okay, in mathematically, how should we represent? So therefore, we have so many solutions here, but we will see which solution we will follow. Okay, just in a while. But before that, let's just spend some time to see what does this solution looks like. Okay, this f of z plus ut or f of z minus ut, how does the solution looks like? And this f can be any of this function, because now I'm not worried about that function. So for example, in this graphical representation, I'm assuming that my function f is some sort of a triangle. Okay, let's assume. And why I'm using this triangle? So that it will be easier for you guys to understand what z minus ut is doing. So I'm taking f of z minus ut, and I'm seeing that this is a function f of 0, which is a sort of a triangle, because this is at time t is equal to 0. It is here. Okay. Now let's see. As time passes, and let's see at time t0, what will happen? So what is happening here? So at time t0, this is becoming f of z minus ut0. Now, what does this function means? F of z minus something. That means it's a function which is f of z, which has moved to the right. Which has moved to the right. By how much? By this value. So ut0. So it has moved to the right with the value of ut0. And this peak value is your f of 0. Okay, so let's not worry about this. So what is happening? Now, if you see, if you pay attention to the solution, what we are seeing is this is a solution which, when I freeze, they are here. But when I release both time, when I release the time, then what is happening? As the time is passing by, I'm seeing the solution is moving to the right. The solution is moving to the right. And along z-axis. So it's a moving solution. So it is moving to the right. But at the same time, it is also varying with time because t is here. So the end conclusion is it's a solution which is varying with time, but at the same time, it is moving forward, moving to the right, because it is f of z minus ut. If I take f of z plus ut, then it will be the solution which will be moving to the left. It will be the solution which will be moving to the left. That is minus z direction. This is minus z direction. And if it is z minus ut, then it is a solution which is moving in the right direction, which is positive z direction. So such kind of solution or a wave is called as, where it is. Yeah. So it's the solution of this f of z minus ut, the solution is nothing but it's a wave, because it is now has a capability to travel. It has a capability to travel in the space, and also time is already there, but it is traveling in space. So that's why it represents a wave. So that's why we are using a word wave. It can travel, and it can travel along the positive z direction if I'm taking f of z minus ut. Now, what will be the speed? What will be the velocity by which it will be moving? So it's very simple. So what we do, we just find delta z over delta t0. That means how much distance it has moved, by how much time has elapsed. So if I'm looking at t0, so for time t0, it has moved this much of the distance, which is u times t0. So u times t0 divided by how much time elapsed, t0. This is nothing but u. So this u represents the wave velocity. That is, what is the velocity at which your solution is moving along the z direction. So this is called as wave velocity. And in electromagnetics, it is given as 1 over root of mu epsilon. This is called as wave velocity, 1 over root of mu epsilon. And as I told you, in a similar way, z plus ut represents a wave in the minus z direction, but the wave velocity is the same, which is 1 over root of mu epsilon. So therefore, in summary, what did we see in summary? In summary, we saw that this 1D scalar wave equation, its solution is a wave, and it's moving either in positive or negative z direction, and with a wave velocity of 1 over root of mu epsilon. And this wave velocity has a special name in electromagnetics, and this is called as phase velocity. It's the velocity at which the phase is moving, because this will be representing the phase. So at phase will be moving. And therefore, there are so many solutions, as I told you, we have. But which solution we are going to take? Now, if you see here, which solution are we going to take? Maybe can anybody comment on this? We have seen so many solutions. Yes, Mr. Abdul Rahman Al Mushrif, can you tell me which solutions we are interested in?
Not sure.
Not sure. Mr. Abdullah Ali, can you tell me? Yes, Mr. Abdullah Ali.
Yes, doctor.
Yes, can you tell me, as I told you, we have so many solutions satisfying this equation, but which solution do you think? What should be the F do you think we should consider here? No idea?
No idea, doctor.
Yes, no idea. So see, as I told you, these are solution, but which one should we use? Anyone now? I'm opening it to the complete class. Which one do you think should we take it? Because this is just a mathematical representation. So we are representing it mathematically. But when we represent mathematically, we also have to use logic. So which one should we use here?
Is it the sinusoidal?
Exactly, yes. We have to use the sinusoidal solution. We will use, either you can use this one or you can use this one. We use sinusoidal solutions. And what is the main reason of using sinusoidal solutions? What is the main reason of using sinusoidal solutions? Why we decided to opt for the sinusoidal solution? I think now you should be able to answer. Why?
Because it's a wave.
Because
they repeat themselves with time.
they repeat themselves. Okay, I agree, but there is even another very important reason.
Because the wave itself is sinusoid.
Maybe no. Think from who is generating them. Maybe you will not get it. No idea? Who is going to generate these waves? The sources, right? What kind of sources do we have in our real world or in practical?
And
Sinusoidal sources. That's the reason. So we are doing it mathematically. But let's try to relate to the reality. So in reality, yes, these are the waves that I'm visualizing it in free space. But really, who is generating that? A source is generating that. But in real, what kind of sources do we have? In real, we have all sinusoidal sources. We have all sinusoidal sources, a voltage sources or a current sources. So therefore, it becomes very logical that we use a solution of f which is sinusoidal in nature. And that's why we use sinusoid. And we use either sine or we use either cosine. But we don't use this because our sources we don't represent in this manner. And out of these two, as everyone knows, as that this is the mostly used one. When we say sinusoidal sources, we usually represent a cosine, not a sine. So therefore, here also we will consider f, our solution, as a sinusoid, okay, which is a cosine. And if we use that, then we have here. So now I'm assuming it as I'm assuming my electric field E has only one component, only EX component. So that's why I'm just saying that only I have this component EX. And then just now we have done that my F is a function of only Z. This F is a function of only Z. So therefore, I'm also saying Ez is only a function of Z. Ex is Z comma T. So therefore, my Ex will be Ex of Z plus or minus Ut. And this, if we use our sinusoidal solution, we represent it in this manner, which is E naught cos of omega t minus beta Z. Okay. So I think, guys, we will stop here and we will prepare for the quiz. So please, you can turn on your cameras, your side cameras. Please turn on your side cameras and then just make yourself ready and keep the calculator with you.
Are we going to upload the solution?
No, I'm going to yes, you are going to upload the solution as we did it in the last quiz. Fast, please arrange yourself. Okay, so let me,